We've been looking for this gene for like 50 years, and now these guys have finally found it. Morphine, nicotine, caffeine, quinine, these are all alkaloids that are made by plants as defense mechanisms. They are heterocyclic rings with a nitrogen. One of the carbon atoms has been replaced by nitrogen. They all come mostly from amino acid. The question is, how exactly do plants make this happen? Because an amino acid, which is a linear chain, you got to now turn this into a ring. Okay, let's start with the substrate lysine, which is the amino acid. Okay. And this lysine is going to go on to make like securinine, some alkaloid that we're interested in. The problem is the following: when lysine goes through and becomes this alkaloid, there's an intermediate compound called cadaverine. Lysine is not symmetric. There's going to be a process called decarboxylation where you take that carboxyl group out, and now it becomes a symmetric molecule, right? If I were to look at this molecule cadaverine this way, and then I were to switch it around, it would look the same to me. Okay? Now, if that is an intermediate, then what should happen? Another enzyme would take that intermediate, and then it could grab on one end, or it could grab the other end.
Right.
Because it's just freely floating around. So this next step enzyme is going to grab that. And if I were to do radioisotope tagging of this molecule, and I were to make a ring out of it with the nitrogen on one end, the radiocarbon could be either on the left or the right. Right? Because the whatever molecule turned it into a ring grabbed that cadaverine from either the left end or the right end. Okay? These are called stepwise symmetric. Okay? Now that happens in some plants, but in other plants, that tagged carbon is always going to be on the left of the nitrogen.
Interesting.
What could be happening at the chemical level such that my enzyme is always grabbing one end, right, of a symmetric molecule? We come to a hypothesis that was given in 1973 by Leisner and Spencer. They said the only way that this can happen is if there's a single process that goes from amino acid, strips the COOH, and then makes the ring. If that intermediate cadaverine were to go and freely float around, there's no way that the next enzyme would grab one end. This only happens if, let's say I'm the enzyme. With my right hand, I grab the amino acid, I strip the COOH, and then I put it to my left hand and I make a ring, right?
Yes.
I'm doing it in one smooth process.
Yes.
There's not, I'm grabbing it, I'm letting it go, and there's some other guy who's grabbing it. Because if the other guy grabs it, it's had time to tumble in the 300 Kelvin environment of the cell, right?
So it has to be an end-to-end process.
Yes.
That is self-contained from start to finish.
Yes. And this was in 1973.